This video is on diodes and diode bridges. Question 1. Draw a voltage versus time graph for a battery, resistor, ammeter, and voltmeter in a circuit. The current versus time graph takes on the same shape. So here in this circuit we have a battery, resistor, ammeter, voltmeter. And the voltage versus time graph looks like this. It's very constant. Now remember, in current versus time graph looks the same way. You get constant current. Doesn't increase or doesn't decrease. Question 2. Use a pencil. Draw a voltage versus time graph for an AC source, resistor, ammeter, and voltmeter in a circuit. The current versus time graph takes on the same shape. So question number 2, the circuit diagram is exactly the same as question number 1, except instead of a DC source, direct current, we have an AC source, alternating current. So you see here, the voltage from the voltmeter is going to increase and then decrease to 0, then increase in the negative direction, then decrease to 0, then increase positively, then decrease to 0. Once again, it just repeats. So it's like a sine curve, okay? It's like a sine wave. Once again, the current versus time graph takes on the same shape. Okay, so we get current increasing in speed in one direction, then it decreases speed and it stops. Then it increases speed in the opposite direction, and then it decreases its speed and it stops, and then this keeps going. So you can see the current is just like vibrating the electrons. Question 3. What does a diode do? Draw the symbol of a diode. A diode is a device which lets current flow in one direction only. It converts AC to DC. When using only one diode, half of the energy of an AC source is lost. Half the time the current travels in one direction, and the other half the time there is no current. Question 4. Draw a voltage versus time graph for half-wave rectification. Once again, the current versus time graph takes on the same shape. So this is what it looks like. We have an AC source, we have a diode, and we have a resistor. So take a look at this graph. The voltage increases from 0, then it decreases to 0. And if there was no diode, we would get negative voltage. But since in a diode, current goes in only one direction, and instead of negative voltage, we get 0 voltage. So we're only getting positive voltage here. So this is a good thing because voltage and current is only in one dimension. Voltage and current is only in one direction. And it's bad because half of our energy is lost. So let's start at the very beginning. Question 1, this is ideal. Voltage and current are in a straight line. Question 2, this is not ideal because voltage and current are changing directions. Question 4, this is better because voltage and current is both in one direction. Unfortunately, half of our energy is lost. So how can we make up for this? Question 5, what is a diode bridge rectifier? What does it do? Draw it. A diode bridge rectifier converts AC to DC with no energy loss. Okay, so take a look at this image on the left. We have an AC input on the left side, and on the top left, we have current going to the right. So the current could only go down through diode 1. It cannot go through diode 2. So it goes down through diode 1, then it goes from point D to point C, and then it goes down through diode 3, and then it goes from point B to the left, to the negative part of the AC input. So then it goes back up, current goes to A, down through D1, diode 1, from point D to point C, down through diode 3, then from point B to the left, up. So this keeps happening. You see on the left side, the image on the left, there's no current going through diode 2 and diode 4. Now take a look at the image on the right side. The image on the right side, now the current switches direction. It starts from the bottom. You see that little positive sign on the bottom? It says AC input on the left side, and on the bottom left, there's a positive sign in red. The current goes to the right through point B, then up through diode 4, then to the left of the resistor to point C, then through diode 2 to point A, and then to the left. Then it goes back down to the positive sign, to point B, through diode 4 to point D, through the resistor to point C, up through diode 2 to point A, then to the left. So you see in both images, it doesn't matter if current goes clockwise or counterclockwise, the current always goes from right to left through the resistor. So please write that down because it's important. The current always goes from right to left through the resistor. Question 6, draw a voltage versus time graph for full wave rectification. The current versus time graph takes on the same shape. So now we have full wave rectification. You see the voltage starts from 0, it increases to a maximum, goes down to 0. Then it doesn't switch direction. It increases to a maximum, then it goes down to 0. And that's 1 revolution, or 2 pi. So the same graph is current versus time. Current increases its speed, then it decreases to 0. Then it increases, and then it decreases to 0. Increases, and then it decreases to 0. Now, problem number 6 doesn't give us the same graph as problem number 1. Problem number 1 is a horizontal line. That's an ideal situation. So how could we get problem number 6 to look like problem number 1? We could have this diode bridge and we could add a capacitor to smooth this out. So question 7, what is the benefit of adding a capacitor in parallel with the diode bridge and resistor? Draw a curve of the output voltage versus time with the diode bridge and capacitor. The current versus time graph takes on the same shape. So the direct current from the diode bridge looks more constant and smoothed out when a capacitor is discharging. So in this circuit diagram on the top, we added a capacitor here. Okay. And now let's check out the voltage output in the current through this load. So look at this image, this graph on the bottom. The voltage increases from 0, and then here it says capacitor discharges. So you see when the capacitor discharges, we get this black, almost horizontal line. And then continuing on with this black curve, the capacitor charges, and then the capacitor discharges. And then the capacitor charges, and then it discharges. Okay? So the black curve here, it says waveform with capacitor. The red curve here says waveform without capacitor. So this is problem number 7. So problem number 6 is the red curve. Problem number 7 is the black curve with the capacitor. Once again, this almost horizontal black line is the discharging of the capacitor. And this very short black curve is the charging of the capacitor. So you see this black curve looks very similar to a horizontal line that we saw in problem number 1. So that's the benefit of a bridge rectifier, a diode bridge, and a capacitor. It converts AC to almost DC.